Hello everyone, welcome back to Data Engineers Academy. In this video, I am going to demonstrate a practical Snowflake use case called historical data recovery using time travel. In real-world data warehouses, data can sometimes be accidentally modified, deleted, or even dropped. Instead of losing the data permanently, Snowflake provides a powerful feature called time travel, which allows us to access historical versions of our data and recover it. In this project, I will demonstrate three important recovery scenarios. First one, recovering accidentally modified data and deleted data. Last one is dropped table. I will also show how we can maintain a recovery edit table to track recovery operations. Coming to the Snowflake, first I am creating a database called time travel demo. So I execute this. The statement executed successfully. Next, I am using the show databases to verify that the database has been created successfully. So as you can see, time travel demo has been created successfully. Now I am creating a schema called recovery inside the time travel demo database. Then I am setting this database and schemas as the current working location. So I will execute this. Schema recovery created successfully. After creating the database and schema, now I am creating an employee table. This table contains 5 columns: employee ID, employee name, department, and salary, and joining date. So now I execute this. Table employee successfully created. Then run desk table employee. Here I am using desk table to verify the table structure and make sure all columns have been created correctly. After creating the table, now I am inserting 5 sample employee record. So I will execute this. So here number of rows inserted is 5. After inserting the data, I am selecting all the records and ordering them by employee ID. So I will execute this query. Successfully executed. Next, before demonstrating recovery, I can inspect the table using show tables. Snowflake time travel allows us to access historical data within the table's configure retention period. For example, if the retention period is 7 days, historical data can be queried for up to 7 days. The exact available retention depends on the Snowflake edition and configuration. Then select current timestamp. So I will run this. This is useful when demonstrating timestamp based time travel. Now let's create a real world problem. Suppose an employee's salary was accidentally changed. Originally, Pravalika's salary is 60,000, but because of an accidental update, the salary has now been changed to 10,000. This represents a data corruption scenario. The important question is, how can we recover the previous value? The first method I am demonstrating is offset based time travel. Here offset minus 60 means that Snowflake attempts to query the table as it existed approximately 60 seconds before the current time. If the change happened more than 60 seconds ago, we can increase the offset. For example, this is useful when you approximately how far back we need to look, but we don't know the exact timestamp. So I will run this. As you can see, number of rows updated is 1. Then I am selecting the employee table where employee ID equals to 101. I will run this. So you can see Pravalika's salary is 10,000, but before the salary is 60,000, right? So how can we solve this problem? Using the offset method. So I am running this query. Here we can see Pravalika's salary is 60,000. The second method is timestamp based time travel. Here I am telling Snowflake to show me the table as it existed at a specific timestamp. This method is useful when we know the exact date and time at which the current data existed. And after that, another powerful approach is to use the Snowflake query history. Here I am searching for queries that contain update employee. The query history gives us information such as the query ID, query text, start time, end time. The most recent result gives us the query ID of the accidental update. Then use your actual query ID. So I will run this. As you can see, this is my query ID. So I will copy this and paste it here. Then run. So the statement ID represents our accidental update. This allows us to see the date before the corruption happened. We can now see that Pravalika's original salary was 60,000. Here, time travel does not automatically change the current table. It allows us to access the historical version of the data. Once we identify the correct historical value, we can use it to restore the current record. Here I am changing the Pravalika salary back to 60,000. So I will execute this query. So statement executed successfully. Let's verify the result. Here the salary has now been successfully restored. And the next one is here, instead of manually typing 60,000, we can recover it directly. I can retrieve the historical value directly from the Snowflake Time Travel. The subquery retrieves Pravalika's historical record. Then the update statement uses that historical salary to update the current record. This approach is more reliable because we are recovering the actual historical value rather than manually entering it. So I am execute this query. So here the error is raised, that is the request time is either beyond the allowed time travel period or before the object creation time. So we will fix that. Here we will change the ID, right? Go back to the before query, copy this and paste here. Now run this query. So statement executed successfully. Next, I will verify the result. The salary has been successfully restored. This is the two approaches for recovering the data. After creating the table, I verify the result. So I will run the select statement. As you can see, all the 5 records are appear here. So next, moving to the next one. Here I will drop the table. You can see employee backup test successfully dropped. Next, verify the result. SQL compilation error. Employee backup test does not exist. Then now comes one of the most useful time travel recovery feature, that is undrop table. Using this command, Snowflake can recover the drop table within the applicable retention period. After running this command, I can query the table again. iDrop table has been successfully recovered. So I will execute this. Statement executed successfully. Next, I will verify the result. You can see drop table successfully recovered. In Snowflake Time Travel, we can also use historical data to create a separate recovery table. Here I am creating the employee recovery using a historical version of the employee table. This can be useful when we want to preserve historical data separately for investigation, validation or recovery purposes. Now I am creating the employee recovery table. Table created successfully. After, I will verify the result. So you can see data has been created successfully. Finally, I am creating a recovery audit table. This table allows us to maintain a record of recovery activities. It contains the recovery ID, table name, recovery type, recovery reason, recovery time, status. So I will execute this query. Query executed successfully. After creating that recovery audit table, I am storing the table name, recovery type, recovery reason, recovery time, status. So I will execute this statement. Executed successfully. After that, I am verifying the result. So you can see employee, table name is employee, recovery type, update recovery, recovery reason, accidental salary modification, and time and also status. So in this project we demonstrated how Snowflake Time Travel can help recover data from different types of accidental changes. The main advantage of Snowflake Time Travel is that we don't need to maintain a separate backup table for every change. Within the applicable retention period, Snowflake allows us to access previous versions of data and use them for recovery. Thank you for watching my video.